Hello, hello. This will be the first potential video in a series, uh, a game designer's guide to Google Sheets. This episode is on iterative calculation or circular calculation references. I kind of want to do more than what most of the videos and guides are showing people. I want to show you what it is, how to enable it, and then some like cool use cases as a game designer making games using Excel as an IDE with formulas. Um, and there might be some of these that translate to real world functionality within like um, the financing industry or any kind of industry that uses data within Google Sheets or Excel. So first off, iterative calculations are circular references. So it can be a cell referencing itself or two cells referencing each other. And usually you'll get an error window that pops up saying, hey, like one or more cells are referencing something else. And then it'll tell you to go to File, Settings, Calculation, and then Iterative Calculation on or off here. And when you're here, turning this on will enable all this to work, which is exactly what we want to do in this lesson. And I think it will be beneficial to kind of get experience utilizing it because it can be a very powerful tool to making your sheets do a lot more than you ever thought possible. So I would say on the screen, the first thing you should be considerate of is the max number of iterations. Now, by default, I do believe it is set to 50 on every sheet. I would say set that to 1. The difference between 1 and 50 is this says how many times do you want this iteration to calculate within each recalculation step. Okay, and I know it sounds weird when it comes out like that. So what that means is, let's say there's basically two different ways you can calculate iterations. You can do step by step, so one calculation per recalculate, or you can try to get a mass recalculation that occurs. So the way I see this happening is if you're working with an ELO system or any kind of statistical data set that you're trying to calculate like a range on, you may want this number to be higher. However, if you're doing game design, calculating health, stats on a character, random event chances, you want this to be lower on a turn-based strategy type of situation. Now, on top of that, you can also adjust this to have a system clock recalculate the sheet on an interval. This I don't think I've ever messed with this, or nor have I seen it prior to trying to record this video. I don't know how new this feature is. Seems kind of snuck out. It might have been here for a while. I wouldn't know, but this is great as you could really gamify your sheets if you're trying to make interactive video games that people can play, or even trying to make predictive models that you can try creating, I would say, artificial data out of. So this could be a really cheap and easy way to make artificial data, which I think in a different video I can kind of go over what that means and how that can be useful. But for now, we're going to keep that on change, on 1, and threshold 0.05. The threshold is important for ELO systems and any kind of float values. You don't want this to recalculate forever because it takes system resources. So if the change between each recalculation step is within this amount, it stops it. Cool. So here I have a couple of different examples. I have some suggestions and hints, and I also have some controls up here. Well, really one control and 4 dice rollers of different types. So really quick, I want to get over the dice rolls and explain what they are. So we have rand 0, 1, 1 through 4, double random, which is 0, 1, and 0, 1, reading next to each other as a concatenation of each other. So you will get 0, 0, 0, 1, 1, 0, 1, 1. So you're creating binary with this. which can be really cool for doing a fancy 1 through 4. And then a character random, which gives you every character between A through Z as a capital letter, which we'll be using for some of these examples, namely this one. Now, a couple things to note. The first two suggestions here go over some really cool locking control features that I think are insanely important when you're trying to utilize these in any kind of sheet that depends on these calculations to work correctly. If a calculation breaks, it can break your entire sheet. To prevent that from happening, having a locking mechanism here, which is the second bullet, will always reset them to a default value that you select, which if you program your sheet correctly, your code will always be prepared for these values to show. So it makes it easy for you to prevent your sheet from breaking and to add some redundancy. Additionally, if there's an error from your sheet, error checking tools can also prevent it from breaking and then also give you kind of a warning signal of what could be wrong with your sheet. Of course, you don't have to use these as a warning checker, but you will occasionally see that I am using these functions within these different codes here. Oops. So you will see those. I think I only have... Okay, I have an if not right here as well. All right, so getting into it, how do you write an iteration? Simply enough, your easiest way to do this is one of two ways. You either reference two cells back and forth. So G11 is the cell I'm in, so let's make that G12. And then the cell below it becomes G11. So you can see now those are referencing each other. And then, let's do, if I can type +1, you can see it becomes +1. That's also +1 of itself. That's an iteration. That is circular. It is a great start. Our first real command that we're going to learn with these, and you've probably seen this a million times, is a logical expression on an if statement. So like D3 equals 1. And then our true would be the cell that we're in, which is H11, plus a value. And then the false will be H11. So it either grows or it stays the same. So we can sit here and calculate the sheet a couple times, and we'll see 1, 2, 3, 4, 5, 6, 7. So you can see it grew a lot. And every time we recalculate, there's a chance that this grows. You can see these also grew because they're iterating every round. They're growing up by 1. So you can see that happen here. So we have constant iterations and we have dependent iterations as a simple if statement. The possibilities explode very rapidly in these. So I don't have this in order, but bear with me. So you can have it set, and I know I have everything disabled right now. If I turn this to true, I'll start these, but I don't want to start them just yet. So I want to give an example of a step up from this. So we go from here to here. This is the same thing with our fail protect and our reset. You can see the values are set here to 0. But that is functionally the same thing as what's here. And then we get into a slightly crazier thing. Let's say you want to work with letters and words and strings rather than numbers. You are able to do that with concatenation, using one of your values as the cell that's in it, and then whatever you're trying to concatenate after. So this is the exact same thing with just an additional step, and of course it reads itself as that value. So you can see here automatically on the first step, rand1 d3 equals 1, concatenate b to the end of it. And every time we get a 1, you can see more b's are added to the end of this forever. Now, this gets a little crazy because we can get into something like this. Now, I will talk about this code in just a second, but it's basically doing this with extra steps. It moves a little slower, and I'll explain why that's useful in just a moment. In the meantime, I want to go over these suggestions here on the side. So we have our two here that are our error checking and our fail prevention checks, which are great. And then we have our step here talking about concatenation, which references this cell, or it kind of shows an example of how to reference that cell. And then we get into step delays and stuff. Ironically, I've misnamed this a little bit. This is more, this is stepped iterations, but it's planned delay. It's not artificial or not like a natural delay that occurs. This is all pre-programmed, and that's done with greater than statements of the previous item. In this case, step delay is when you have a lot of data trying to process at the same time, or you have a lot of iterations that in different cells that are referencing each other down a line. So like let's say F15 is referencing F16, which is going to F17 to 18, or sorry, I'm going by rows, not columns. But you get the idea. If I had all these referencing down past each other, it's going to create a load on the system. You might catch delays. So I have noticed this problem mostly in Google Sheets, not as much in Microsoft Excel. The problem still exists though. I have an example of a game that I created as a test, which is an ASCII RPG. I'm not going to go too much into this code now, but you will see lags and delay with the movement code here. So if you can see the delay there. That was a solid 4 or 5 second delay to calculate the change. I think that's more of a problem with the natural limitation of being a web browser based spreadsheet versus an application spreadsheet, but you will still find use in this. It's just it's good to keep in mind that you may experience jumps or lags in the work you're doing, especially when you're working in custom generation of data with iterative calculations. Moving forward, we can get back into the locked out values and how these are different. So these are intentional delays that are operating as necessary. And the way they work is you are limiting it from iterating until a certain thing happens. In this case, it is forcing the cell above it to hit a value and then start calculating. You can see the delay there. So these are fundamentally different from each other, but I know that might be a bit hard to understand and grasp. So I may have to make further tutorials in the future that kind of go over actual use cases with data sets that can be attempted with. And then finally, cells can check and read their own contents. So kind of how I briefly mentioned this before, but I'm going to start with this one first because I think this one is easier to grasp and understand fundamentally, and is doing the same thing as this is. Just this is with numbers and this is with letters. So cells can check and read their own contents. That's one of the cool perks with iterative calculations and circular references. Before it used to be, I need to check H17's contents to do something else, right? But now it's like, oh no, I just need to check my own contents and do something with my own contents. And the way we do that is just directly checking if we're at a value greater or equal to something or less than something with numbers, or we are using a find function or a regex match if we're looking for an exact string match to find a certain string and then doing something with that. And I'll explain why this looks weird in a second. This was causing me a headache earlier. It forced me to re-record twice. So here, simply enough, This looks super complicated, but it's just a repeating formula a couple times doing two different things. So we are first checking that if the value in here is greater than 10. If it is, then we will add 2 times whatever's in F3 here. So it's going to be 3 times 2 is 6, added to whatever to this 8. Now, since this is less than 10, it's 8 currently, that's actually going to throw a false, and the false function is just going to add 3 to it instead of 6. So this might be useful if you're trying to do some kind of leveling system, or you're trying to do stack number checking, or maybe you reverse this and do kind of a drop off. So like a theoretical maximum chart. Those are things you can look at doing with a function like this. So it's super, super functional and useful. I can see this being used in a lot of cases. And pretty easy to set up. It's just a lot of circular reference, and you kind of have to learn what is happening here. But we're really only looking at 3 things, which is not too bad. Now, the real beast of this entire sheet is this monster here. I spent a good 30 minutes trying to write this code because naturally there's not a lot of documentation on this stuff. It's very difficult to understand. But ironically, the issue wasn't what I was doing. It was just me not writing my concatenation correctly. Ironically, concat needs 2 functions to read, and I was writing 1. So what's happening here, we are using the find function to find if a certain letter exists in the string of letters. If it does, we're going to replace everything with winner. If it doesn't, we're going to attempt to add a letter to it from the character random screen. Just any letter that occurs, but it has to be when this dice equals 3. So every time that equals 3, another letter is added. So we can actually test this out now. So you can see an S just got added. I'm going to do a couple. And naturally, this is going to be very, very slow to complete itself because of the nature of trying to get a G letter in the character ran while this is 3. So that is whatever 4 times 26 is. 104. That's a 1 in 104 chance for that to occur. Every single time it happens. So you can see it takes a while for it to happen. But what's nice is this is a great tool for doing kind of custom events or secret locks and stuff. If you're trying to do kind of, you can set this up to check for any of these letters. You can stack this 100 times and do different things on what it's doing. So if you're doing a game like Doki Doki Literature Club or anything that has like I would say even Undertale might be a better example. If you have a seed, this almost operates as a seed for you in a way. Naturally, you could just generate a seed and work with that, but in the simple, without having to make your own seeds, this is a cool way to do stuff dependently. So whenever, let's say you have it set to read for, instead of G, you have it set to A, and then on top of that you also have it set to check for B and C together for something else. Now whenever you're doing a run of a game, whenever you start it up, the first time it hits either 3 of those values, either item number 1 is going to happen or item number 2 is going to happen, and item number 2 has a higher % chance of hitting than item 1. So you're creating a rarity and it locks out after. So this is a really cool way to do that. Other use cases for a system like this is data encoding. So if you're trying to shorthand complex code, so like let's say you have H stands for 101 and then like V stands for 256. Whoops. 256. Now all of a sudden you're creating complex code and doing almost like a reverse binary or not even a reverse binary, but you're doing encryption. So you can set this up to work to encrypt or decrypt things with preset values and some other formulas using a similar method. You may have to change it out slightly. And then we're going to clean our screen up a bit here just because it got messy. Anyways, this is my tutorial for now. I don't have much left to show you, but before you go, I'm going to do two things. I want to quickly show you this and give you some actual examples of where I've used iterative calculations within my own code on this RPG. And then I'm also going to leave a copy of this template in the description of the video so you can actually copy the template and look it over, mess with it, changes you need, and use it kind of as an experimental bed for you to practice iterations and develop new techniques and ideas. If you find any really cool ones, feel free to share them in the comments below. I would love to see what you come up with and any like really neat use cases. Who knows, maybe it turns into another video in the future. But really quick before we head out, I just want to quickly show you just some of the code here. This is almost kind of like a brag, but I want to show off just how powerful that single function of Sheets and Excel is. So I built this game back in 2021 is when I started it. And I worked on it through most of 2021 and 2022. I haven't really picked it up since. It's been about 2.5 years since I've touched it, but I think this is one of the most complex systems I've ever developed in anything. Now, the things I think are really important here are there are iterations here for XP calculation. We have character AI with code shortcuts that is fully functional. We have respawns and movement scripts, health and damage. And then we have player stats, which are fully iterated. So these bars here that you see, these will actually fill up and change as the player gains experience from killing monsters. The player can also take damage and die, so that can drop as well. So you can see how these are set up to have different values. And I'm very proud of the system because it's honestly very pretty. This will glow yellow as it fills up, and then once it resets, it'll drop to 0. This will turn to 2, and then your other values within the player, like level, max health, current health, mana, everything will change, including your attack and defense and critical strike stuff. So all that is coded into the game, and it all uses iterative calculation. Now, it's easy enough. You can see I've practiced this where I have it set to turn off. You can see how those turn off the moment I do that. I think, there we go. So you can see that they're turned on now. But there is that delay I was telling you about. So you can see how complex this gets. I think most use cases won't be as big as this, but you might be able to come up with some interesting simplified games, or even use this kind of code within your own professional template, especially with like predictive modeling and stuff. If you're trying to create custom data information, using like array formula would be a great way to expand iterative calculations to create a custom data set that grows on its own, that you can just populate on the fly, and it would be fully dynamic and custom to you. But this is the end of my video. Thank you so much for watching. Like I said, if you enjoyed it, or if you found this helpful, please let me know in the comments below. Let me know if you found any formulas that expand on these ideas or are completely different. And hopefully I see you for the next video. Bye-bye.